Multiplying radical expressions. So you learned how to simplify radical expressions. Of course, what we're going to do now is apply some operations. One of those operations being multiplication. So there is a property that you need to be aware of, and this is called the product property of square roots. And what it states is, when you have the square root of a number times another number, and notice how they're both inside the square root, we are allowed to say or to write it in this form: a times the square root of b. So basically what we did is we separate a and b, but they both have their own radical. Not just any radical, the square root radical. Again, if you don't see a number here, there is an invisible 2. So we refer it to as a square root. Now, this property can be written vice versa. So let's say we had the square root of a times the square root of b. We are allowed to actually write them inside the same radical, a times b. But there's a catch. We can multiply radicals if and only if they have the same index. In other words, if they have the same root. So let's pretend I had the square root of a number times the square root of a number. Then for sure I can use this property. But if I had the square root of a number times the square root of a cube root, I'm sorry, I shouldn't have said square root, the cube root of a number, here we cannot use the property because they don't have the same root, they don't have the same index. So with that being said, let's go ahead and try an example here. Multiply the set of radical expressions. Be sure to answer in simplified. Your answer is simplified. So here we have that square root of 10 times the square root of 5. What we're going to do is we're going to apply the property, and we're going to say 10 times 5. Now there's two ways to do this. There's a long way and there's a short way. The short way is, instead of multiplying these two and getting the square root of 50, what we're going to do is we're going to simplify these two factors, these two numbers here, these two multiples. So factors of 10 are 2 and 5. Factors of 5, well, it's just a 5 because it's already prime. Since we're dealing with the square root, we can put them in pairs. So because we use the product property of square roots, we have a pair of 5s. So remember, anything that did not get paired goes inside the radical. This pair, I'm going to write the value of it only once, and we found our answer, 5 square root of 2. Now, let's say you would have multiplied them, 10 times 5. Then you would have said, okay, what are the factors of 50? 2 and 25. Factors of 5. 5 and 5. So what we do is we would have to circle the pairs. 2 did not get circled, so 2 stays inside the radical. This quantity, I'm just going to write it once. And as you can see, we would still end up with the same answer. But of course, it took a few more steps, and that is okay. Either method is correct, as long as you get the same answer. Okay. Next one. 24 times 3 square root of 6. So, what we're going to do is we're going to rewrite this, and we're going to use the commutative property of multiplication, which allows us to regroup or rewrite actually things in different ways. So this 3, I'm going to write it here, and I'm going to apply the property that says that you are allowed to do this. Square root of 24 times 6. Instead of multiplying 24 and 6, because they end up being a pretty large number, I'm simply going to start breaking these up and finding its factors. So factors of 24, I can use, let's see, 4 and 6. 4, I can break it up into 2 and 2. 6, I can break it up into 2 and 3. And this 6 up here, 3 and 2. So we are dealing with the square root, so put them in pairs. There's a pair of 2, there's a pair of 3, and lo and behold, there's a pair of 2. So you need to ask yourself, was there any value that did not get paired? The answer is no. So this pair, I'm going to write its quantity outside once. This pair of 3, pull it out once. This pair of 2, once. But let's not forget that at the very beginning of this problem, there was a 3 outside of the radical already. So we multiply it. So, since we did not have a number that did not get paired, left behind, there's no need to have this square root. Instead, our final answer is the product of all these numbers, which is 3 times 2 is 6, times 3 is 18, times 2 is 36. So our simplified answer is just 36. So again, you could have done 3 and actually multiplied 24 times 6, and you could have gone 144. And if you would have remembered that 144 is actually a perfect square, 12 and 12, well, here's a pair, 12 and 12. It's a perfect square. So our answer would have been 12 written outside of the radical. We wouldn't have needed this radical. But don't forget that we had a 3 to begin with, so if we multiply those two, we still would have gotten an answer of 36. But of course, we don't always remember our perfect squares, so this may not always work for us. This, however, does. Let's try another one. Square root of 81 times the cube root of 4th. Some of you are already doing this. Oh, okay, so 81 times 4. Nope, you cannot do that. We cannot multiply these two. They do not have the same root or the same index. So we can't even multiply them. Moving on to the next one. So what we're going to do is, again, we're going to rewrite this, but we're going to apply the property. Coefficients always go first in front of variables. So I'm going to put the 5 there. X cubed times x squared. Now we just learned about properties of exponents. When your bases are the same, we can add the exponents. So we have 4 square root of 5 x to the 5th. So we are going to start breaking this up. 5 cannot be broken up into anything because 5 is prime. X, however, I can expand, and I can group in 2's because this is a square root. The one that did not get grouped, that stays inside my radical, so for sure I need a radical. But the 5 is also in there because we weren't able to break it up anyway. We had 2 pairs of x's, so x squared. And don't forget that we had a 4 outside of the radical to begin with, so it needs to stay there. So this would be our simplified answer. Next example. Multiply the set of radical expressions. Be sure your answer is simplified. Okay. First thing you want to ask yourself, is it the same root? Same index, same root, so we are allowed to do this step. 54 times 28. Now, I'm really not going to multiply 54 and 28 because they will result in a really large number. So what I'm going to do instead is I'm going to break these two up within the radical. They're in the same radical. So, factors of 54. So we can say, 6 and 9. Pick larger numbers. 2 and 3, 3 and 3. Factors of 28. Well, there's 4 and 7. 4, of course, can be 2 and 2. 7, it's a prime, so nothing we can do there. Okay, We're going to put them in groups of 3 because that's what our index tells us to do. So here's a group of 3. And then the 2's also forms a group of 3. 7 doesn't belong to a group. So that should already tell you, okay, our answer is going to have a radical. And inside the radical, we're going to have a 7. And this is the cube root. We had a group of 2, so I'm going to write that quantity once. We also had a group of 3's, so I'm going to write that quantity once. We didn't have a number outside of the radicals to begin with, so nothing we are forgetting. Final answer is 2 times 3 is 6, cube root of 7. And that is our simplified answer. Last but not least, we have 2 roots here, square roots to be exact. So I'm going to apply the product property, and I'm going to rewrite this in a way where my coefficients are next to each other and my variables are next to each other. So I'm not going to multiply 15 and 30 because, like I said, it would be too large of a number. Instead, I'm going to break up the 15 to 5 and 3, the 30, 5 and 6, and the 6, 3 and 2. This u to the 7th, I'm going to repeat it 7 times. This u, I'm going to repeat it 3 times. Okay, since we are dealing with the square root, invisible 2, square root, I'm looking for pairs of 2's. So here's a pair, I'm sorry, not pairs of 2's, just pairs of numbers. Pairs of 5's, and of course, same deal here, pair, 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 and pair. Anything that did not get paired up, like this 2, needs to stay inside the radical. So a 2 goes in there. We had a pair of 5, so copy it once. A pair of 3, copy it once. And then we had exactly 2, 3, 4, 5 pairs of u's, so u to the 5th. Our simplified answer will be 5 times 3, 15, u to the 5th, square root of 2. And this is our simplified answer. And that is all for today.